Well, my colleague Jim Maltby has talked to you about all the different flavors of database that there are out there, the relational database and the NoSQL databases and the graph-oriented databases and the Hadoop databases. And I wanted to focus on a couple in particular. Relational, because they're the most common. They're the ones that most everybody has experience with and has worked with before and may be using now. And kind of contrast and compare that a little bit with the graphical database, which is what the Eureka system offers. Now, the way I suggest that you think about a relational database is that it's this set of tables of data. You've got some information that is just naturally represented as rows and columns of information. On a small scale, let's imagine that you're got a list of volunteers from your neighborhood who are going to do some charity project. And so you want to get down everybody's name, address, and phone number, and email address. Well, you'd put that in a spreadsheet. You just put it in a row and column oriented spreadsheet. Why wouldn't you? It's natural for that. You're never going to look at it in oddball different ways and make connections across people's phone numbers and email addresses or something like that. It's very natural to just represent it as a table of information. And relational database is just bigger and more complex than that. It's usually big sets of huge tables with different kinds of information. There might be people's names and addresses in one, and transactions that people conducted in another, and so on. The actual making of connections between them is fairly infrequent, and computationally it's expensive. Now, contrast that with a graph database. A graph database, one example of which is the triple store that Eureka uses, as Jim described, is all about connections between items of data. This protein interacts with this molecule. This molecule produces this chemical. This chemical interacts with this protein and this other protein. You find yourself in a situation where the natural way to express this information is with this big graph, this big network of connections. And the questions you ask from a graph-oriented database are likewise going to be different from the questions that you're going to ask a relational database. Or you might be looking for some pattern in the graph database. Imagine that you worked at the Securities Exchange Commission and you suspected a certain employee of a certain company to be doing insider trading. So you're looking for a pattern, and it turns out this employee, Joe Dokes, every time he gets new information, he sends an email to his friend in California, and the friend in California immediately calls his stockbroker. And the stockbroker makes some purchases. So there's this little pattern that occurs over and over and over every time employee Joe Dokes gets new insider information. So you see that pattern repeated, and you say something's going wrong here. Something illegal is happening here, because you see that pattern in the database. Now, it would be technically possible, but very excruciatingly difficult to dig that same kind of information out of a relational database. And another advantage of the graphical databases is that you can stumble across a pattern that you weren't particularly looking for. Joe Dokes gets insider information, emails his buddy, the buddy calls the stockbroker, and the stockbroker makes 3 more calls to other stockbrokers. You may not have asked for that, but it may get picked up in the course of looking for these other patterns, and you discover connections and patterns that are also suspicious that you weren't exactly looking for. My name is David Mizell. I'm a Senior Technical Project Lead at YarcData, and this has been a Eureka moment.